Good morning to one and all. Today's topic is related to chemical stabilization. In previous classes, we discussed three different types of stabilizations. Those are first one is related to mechanical stabilization. In the mechanical stabilizations, we are used totally mechanical equipments to decrease the content of voids and water content present in the soil surface and ground below the ground levels. In second content, we are observed stabilization of soil by using lime. In the lime itself, we are having a different chemicals, means lime and the slaked lime and lime with magnesium and other other chemical additives with lime. All those are actively participated to form ionic bond with the surrounding particles of the earth crust and surrounding elements, and then they are giving strength to the soil. Similarly, the third we are discussed about stabilization of soil using cement. In the cement also we are used a particular quantity of cement according to the condition of the soil and particle sizes. By using the content of cement, simply we are getting a crystallized strength. Normally in the lime there may be bonding, but in case of mechanical stabilization there may be densification. But in case of cement stabilizations we are forming a crystal bond. Especially this cement stabilization normally we are used for the paved roads. Below the paved roads we have to use this cement stabilization, so that in that particular case we will get a good quantity of compressive strength to the surrounding soils. After those three kinds of stabilizations, we are discussing this chemical stabilization. Normally in the name itself we are having a chemical, that means a liquid matter that will be actively participating in the chemical reaction to get a good quantity of strength to the soil. It may be physical strength and chemical strength in both two cases. Physical strength means improving the engineering properties. Chemical strength means automatically it will have to react with surrounding elements for the formation of bond. First of all, we have to discuss what is a chemical stabilization, how it have to do. That means in what manner we have to go. First of all, chemical stabilization of soil is a method of modifying physical, synthetic, and around within a clay particles which the earth obliques less water to fulfill the static imbalance. That means static imbalance. Static means normally a fixed body we will call as a static. Elastic means simply it is a moving when the application of load. That is the difference between static and elastic. Here we have to get a static imbalance. That means whenever the load is applied on a structure, there may be no movement due to the application of the load. When we get this static imbalance, automatically whenever there is a formation of bond between surrounding molecules or atoms or ions, then only we will get this static imbalance. But in case of chemical stabilizations, we are using simply a chemical which will be actively participated in the reaction. Due to those reaction, automatically the soil particles and surrounding molecules will be actively forming bond, and then they will get the strength. Next one, what we are using different kinds of chemicals, means what are the different types of chemicals we are using in this soil stabilizations. First of all, we have to use this calcium chloride. That means calcium chloride means normally chemical composition of calcium chloride is CaCl2. But in case of lime stabilization also we are having calcium content, but is in the form of CaO, only CaO. And if it is a hydrated lime, automatically it is CaOH twice. And slaked lime CaO plus MgOH twice. But in case of calcium chloride, the calcium is associated with the chlorine content. That is the major difference between this chemical stabilization and lime stabilization. Some of the persons are simply confusing. Sir, in those both two cases we are having calcium, then why we have to read out separately in the chemical stabilization? But in case of lime stabilization, there is no chlorine content. Here we are using a chlorine content. Calcium chloride, simply CaCl2, is generally has a property of hygroscopic and deliquescent. It is used as a water retentive additive in mechanically stabilized soil bases and surfacing. That means normally this calcium chloride is a water repellent. Repellent means simply that will not allow content of water into the soil surface. Then the soil property will be increases. Why? Because if the quantity of water is allowed to the soil, automatically there may be some losing of the property will be takes place. That means normally losing means there may be huge amount of gap between particle to particle. There may be shear strength formed. That means shear force will be formed in the structure due to addition of water. So that this calcium chloride is a repellent to the water, so that simply it will not allow content of water into the soil. Then the total soil particles will be strengthened in the form of mechanical and stabilization basis to the surface. Why? Because the water will be entered on the top surface only. Whenever we are having a rainy season, automatically the water is fed to the earth by top surfaces, so that whenever we are having this content of calcium chloride on the top surfaces of the earth, automatically those will not allow water molecules to below layers, so that simply we have predicting the entrainment of water. Next, third content is the process lowers vapor pressure. That means vapor pressure means simply humidity involves. That means whatever the humidity present in the atmosphere, that is also a responsible factor. Why? Because the earth is in a huge amount of temperature, automatically the earth will absorb a lot of humidity. Particularly in summer seasons, we have to observe the total morning session we have to associate with a huge amount of temperatures. But in case of night, the total earth surface is absorbing water by because of this energy. In the morning time, the earth is totally charged. Due to those charge, automatically the charge may be useful to recharge the content of water whichever is lost due to the sun's energy. Likely here also the process of lower vapor pressure comma surface tension increases. Lower vapor pressure means whenever we are giving these chemical additives to the soil surface, automatically those will lowers the vapor pressure. That means it will not allow water content. Automatically vapor pressure in the earth surface will be lowered. That means decreases. Automatically surface tensions increases. Surface tension increases means automatically surface means whatever the content is decreases, automatically surface tension increases, and rate of evaporation decreases. Rate of evaporation means normally if the water is present on the top layer of the earth, automatically due to sun's radiation the water content will be evaporated. Why? In this particular case we are using this calcium chloride as a top layer. Automatically this calcium chloride will not allow water content, so that this evaporation also decreases. Why? Because there is no water content due to presence of calcium chloride. Evaporation decreases means automatically there may be less quantity of settlement of soil. If the water present in the soil decreases, automatically the volume also decreases. There may be some quantity of shrinkage we have to observe, so that whenever the soil is stabilized with the chemicals, there may be less quantity of shrinkage and less quantity of these forces, surface tension, all those are acting on the soil, so that it will be a good process. Next one, it is also lowers the freezing point of water, and which helps the reduction of frost heave action. Normally freezing and thawing effects. Freezing means whenever the water content present on the soil due to this cold climatic areas, automatically the water will be freezes at negative temperatures, and the so water will be staggered on the below the earth surfaces, and those will cause some quantity of obstructions to remove out, so that those will cause a inadequate conditions, which helps to reduce the frost heave actions, so that if there is calcium chloride layer, automatically those freezing also decreases, and frost even conditions also very helpful for taking further actions. It lowers the electric double layer. That means double layer means if there is an entrainment of water, there will be formation of layer by layer technique, so that if there is no water, automatically the total surface will act as a single layer. The salt reduces the water pickup, and thus the loss of strength of fine grained soils, so that the salt content, whenever there is a calcium chloride, it is a simply salt, so that this salt simply reduces the content of water, and thus the less, thus the loss of strength in fine grained soils. That means loss of strength also simply decreases in fine grained soils. Calcium chloride generally acts as a soil flocculant and facilitates compaction. Soil flocculant means simply it will not allow any content of water or any content of water from the soil and to the soil, so that it simply facilitates huge amount of compaction. Normally compaction means by the means of mechanical action we have to do, but in case of addition of this salt like a calcium chloride, simply it will give an artificial compaction without using any mechanical equipments. Next one is the frequent application of calcium chloride may results in the loss of chemical by leaching action. Normally leaching means a removal of layer by layer. For some of the structures we have to observe this content of leaching action. Why? Because due to the action of frost heaven conditions, that means especially in the season of rainy season, automatically the water will strikes the building surface with a huge amount of forces. In some of the cases the total building structure is associated with some amount of chemicals which will be absorbed by the atmospheric air content. That means normally atmosphere contains some of the waste gases. Due to this calcium present in the cement, automatically absorb those gases, and they will form as a powder on the top surface of the structure. After the hitting of this rainy water, automatically there may be some penetration of rainy water. Due to this calcium chloride penetration into the structure, there will be some flocculation, so that pieces by pieces, simply the total top surface will be removing because of this flocculation action, and facilitates huge amount of compaction. Likely here also there may be compaction takes place due to this flocculation. Why? Because the total rainwater acts as a some amount of compaction technique, so that simply due to those compaction technique also the total soil will be strengthened. Next one is the frequent application of calcium chloride may results in the loss of chemical by leaching reaction. Leaching means simply removal of top surface. Previously we discussed by the action of this rainy water, that is leaching. For making effective application of salt, the relative humidity of atmosphere should be above 30%. That means in which condition we have to prefer this calcium chloride stabilization means automatically whenever the soil or above the atmosphere conditions are having more than 30% humidity. In those cases only we have to use this condition. Because if there is less content, automatically we are using simply salt, so that it will be some quantity of material, and it is also having some cost, so that we don't have to go for huge projects with the financial conditions. Simply we have to choose a small scale financial projects for improving our the strength of the soil. Some of the different chemicals which we are using in our daily life for compaction process are listed here, so that we have to observe those and which cases we have to implement those in the site fields. First of all, sodium chloride is also normally in our daily life, simply sodium chloride is using as a salt. It means we use it as a salt in our food particle, that means food materials. Sodium chloride is also an used for the same purpose with the stabilizing action similar to the calcium chloride. That means sodium chloride also is used as a replacement of this calcium chloride. That means, but in case of sodium chloride, it is somewhat cost more than calcium chloride. Whenever there is a coastal areas, in those particular coastal areas, this sodium chloride will be very cheap, so that in those particular places we have to choose this type of remedy for stabilizing the soils. Next content is sodium silicate is also at another compound that we use to compact the soil with the help of different chemicals. With the help of sodium silicate, we have to use this calcium chloride. That means some content of calcium chloride plus some content of this sodium silicate. Next one, alkali chlorisinase. Next one, siliconites and polymers, chrome lignin, and amines. All those are different chemicals which are not inferior to us. Why? Because simply we are not using those chemicals in our daily life. Simply some of the chemicals are we using, like a calcium chloride and hydrochloric acid and sulfuric acid and a magnesium. Likely those materials are daily we are using in a different purposes, like batteries and other things. But in case of here, different components are listed. Those components are not superior to us. Why? Because those are not useful to our daily life. Those are some preference. First of all, what is the use of these chemicals by using the for the purpose of stabilization of the soil? That means in what cases we have to go for this salt stabilization or chemical stabilization, in which ways those will be beneficial. One by one we have to discuss. The first major benefit is it lowers the optimum water content. That means lowers means automatically decreases whenever we are using this calcium chloride or magnesium chloride or sodium chloride as a top layer. Automatically we don't have to go for dewatering techniques. Why? Because simply this salt materials will repel the water, so that there may be no deposition of groundwater and there may be no recharge of water into the earth surfaces, so that simply it will be very useful and it will reduces the dewatering conditions in our site levels, so that it is these conditions we don't go for large scale areas, only small scale areas we have to prefer for this kind of techniques. Why? Because if we are going with this salt stabilization with a long areas, automatically there will be no recharge. In our future we won't get sufficient quantity of water from the ground level, so that it is not useful in all areas. Only few places we have to implement these kinds of techniques. Next thing is causes a small decrease in the strength of soil. That means a small amount, that means a 2 to 5% of strength will be decreases. Why? Because the total is a salt content, it will decreases the formation of the bond and plasticity index and liquid limits, so that automatically some quantity of strength of the soil will be decreases, and this strength also directly proportional to this bearing capacity. We have to go for artificial improvement of bearing capacity whenever we are using this calcium, that means calcium chloride or sodium chloride as a soil stabilizing agent. Third one is, however, if the compacted soil is put to water emissions, water picks up is reduced and the strength of the soil increases. That means, however, whenever we are going for compaction of the soil is put to water imbibitions. Automatically, water will pick up, reduce, and strength of the soil increases. In this particular sentence, what we have to observe is simply by the usage of this chlorine content of calcium or sodium, automatically they will not allow the water content, so that the total soil will be strengthened, so that we have a beneficial action to don't go for improvement of the soil. We won't have to go for further improvements. Simply they will improve the strengthening capacities by simply increasing the bond formation and strength of properties. A small negative is it will decrease a 2 to 5% of the strength. The remaining strength will be obtained by simply adding those chemical content to the top layers of the soil. The benefits of this stabilization requires the presence of chemical in pore fluid. That means pore fluid means automatically those chemicals will be in the form of liquids only. Raw chemicals will not form a bond to the soil structure, so that we have to use the chemicals in liquid state. That means liquid means automatically the liquid will be easily dispersed into the soil particles, and bond formation also very high content. As the chemical is leached out, the benefits are lost. That means whenever due to these erosional properties of the soil, that means whenever there is a frost action of water on the top surface of the earth, some of the parts will be leached out due to this action of erosion. So that in those cases also we have to loss some quantity of strength, so that we need to replace the content of matter whichever is lost due to the action of frost weathering actions. And next point is its performance depends upon the groundwater movement. That means water movement. In the previous case we have discussed weathering will be takes place whenever there is a rainy season, so that if there is a groundwater movement against our soil, automatically water will absorb some content of salt, and those salt will be leached out through the water also, and the day by day simply content of salt present in the soil will be decreases due to this movement of water in our lands. So that we have to decrease the flow of water in our land whenever we are using these chemical stabilizations. Why? Because the total water will leach out the content of chemicals whichever are present in our soil, so that we have to take an action against this movement of water. Simply we have to increase the slope, and we need to construct a walls around our soil content, so that it will not allow water, or it will not allow movement of water from our soil. Next is its performance depends upon the groundwater movement, and construction methods are similar to those under used for lime stabilization. Simply whatever the methods, that means simply for mixing and compaction methods, whatever we are using for the purpose of lime stabilization, simply those we have to employ in this stabilization of soil with the help of chemical contents. Why? Because both lime and these contents are similar properties. Those two are chemicals, but in case of lime we are having only 1%, that means only calcium content, but in here in the particular chemical we are having only calcium content is there and chlorine content is there, so that two chemical components these are will be in the form of salts. There may be change between the lime stabilization and this chemical stabilization, so that we have to go for same method whatever we are used or prescribed in lime stabilization. The construction methods and similar. Next one is the quantity required is about half percent of weight of the soil. That means half percent means for a particular 1 meter cube of soil we have to go for a densification technique. Simply half of the soil will be replaced with the content of this salt or this chemical like calcium chloride or sodium chloride, so that we have to go for huge amount of these salts for stabilizing these contents. In this particularly we are discussing about this sodium chloride. What is the property of sodium chloride in this formation of this strength? First of all, its tendency for attraction of moisture is somewhat lesser than the calcium chloride. That means simply they are comparing the two salts. First one is the calcium chloride and the second one is the sodium chloride, so that there will be a difference between those two contents. Sodium chloride having less content of water absorption compared to this calcium chloride. And what is the properties in the calcium chloride? It causes colloidal reaction. That means simply colloidal means in water we have to observe these colloidal conditions. Simply one particle is moving and simply it will dashes the another particle, so that it will forms a colloidal actions when they are reacting with another particle, so that it alters the characteristics of the soil. Simply they will change or modify, say, or they will disturb the properties of the soil in the form of colloidal actions. Next one is it is deliquescent and hygroscopic and reduces the loss of moisture. That means previously we discussed the total calcium chloride content will be actively participated and automatically the water will not be allowed to the soil, so that the total will be lost by the action of this moisture. Next thing is it reduces the chances of frost heave as the freezing point of the water is lowered. That means it reduces means simply it decreases the chances of heave conditions. That means whatever the vapor conditions and other conditions, and the freezing conditions also lowered. It will be effective as dust calming. That means effective as a dust calming, so that they will not allow dust particles into them. Why? Because of these chemical actions. That means dust calming means automatically dust formation from the soil will be very less. Normally in our soil we have to observe after after cleaning for 1 day or 2 days, simply the total dust will be forming on the layer of the soil. Why? Because of due to this positive energy and other atmospheric features by the soil. That means not in our daily schedule some of the soil will be absorb the amount of energy from the sun at a morning session, and in the evening session simply they will recharge the water content from the atmosphere. Likely there will be some quantities of actions will be takes place day by day and night. Due to those actions automatically the total waste material whichever is present in the atmosphere, automatically those will be absorbed by the soil particles due to these charging conditions. Effective dust calming, that is the explanation about dust calming. Next one, effective for silty and clayey soils which lost strength within an increasing of water content. Silty and clayey soils means, silty soils means their particle size is very high, and clayey soils means their particle size is very low. Those kind of soils simply lose strength with increase of water content automatically. Why? Because of those two soils will absorb huge amount of water. Whenever there is a entrainment of water in those particular soils, automatically their strength will be decreases due to this breaking of ionic bonds between the particles and movement of water in rapid directions. That means if there is a movement of water in simply one direction, the strength will not be disturbed. Why? Because the total water will be moving in a single line, so that the only that particular direction only we are having movement of water and strength distribution. But in case of movement of water in rapidity, like n number of waves simply water have to move, so that in those n number of waves there will be a disturbance and a decreasing of bond formation due to the entrainment of water. All those leads to decrement of the strength. Next one, it causes a slight increase in maximum dry unit weight. Why? Because automatically those will arrest the entrainment of water particles. Due to those arresting of entrainment of water, automatically dry mass will be increases and wet mass will be decreases. Next one, it forms crystallizations in the pores of the soil and Finally they will dense the hard matter with the stabilization surface. The pores in the soil filled by the retard further evaporation of water. That means crystallization. Normally crystallization means n number of particles. That means n number means simply 100 or 200 particles simply formed as a crystal, so that there will be huge amount of bond formation there between particle to particle. Likely there may be several crystals are formed. Due to those crystals, the strength will be increases and pores also decreases between the particle to particle. Automatically there may be densification due to the formation of these crystallized particles. Likely in the previous case, cement stabilization also, there may be some crystals formed by the bonding of cement with surrounding particles. Whenever we are giving an content of water, there is no water, there may be no formation of crystals. But in case of here, without water, automatically those crystals are formed due to this ionic movement of calcium and chlorine or any other salts. It also checks the tendency of formation of shrinkage cracks. That means shrinkage means normally whenever there is a less content of water in the soil, due to those less content of water, the total soil will be forming cracks. Those cracks normally we are called as a shrinkage cracks. It also checks the tendency, that means reduces the tendency of formation of these shrinkage cracks. Why? Because the total particles are forming as a crystal, so that there may be bond between the particle to particle, so that there will be no formation of these cracks in the structure due to the addition of this calcium chloride. And it is mixed with the soil either by mix in place or mixing by plant. That means mix in place means automatically we have to combine those two contents of soil and sand particles, and we have to use a well graded mixers in the site itself, and those mixed material will be we have to spread in a equi layer manner. Otherwise there may be some difference will be takes place automatically. Due to those difference also, some huge altitudes and high lower altitudes will be forming. The quantity is required for about 1% of the soil weight. That means in the previous case we have discussed 0.5% of the salt will be used, but in case of here the quantity required is about 1% of the soil weight. In the previous case we have discussed about volume content. In those volume content we have to take a 0.5%, but here mass content we have to take a 1% of soil to the salt. Next one is the till now we have discussed about calcium chloride and sodium chloride. After that we are having this sodium silicates, and the next one polymers and chromium like and other chemicals are there, so that we have to discuss one by one in a lengthy manner. Sodium silicate, it is used as a solution in the water known as water glass. Normally silicate means it is a structure present in the glass. Normally sand is associated with these silicates. Normally glass also manufactured by the help of this silica content. Likely here also we are using sodium silicate. Whenever this sodium silicate is mixed with the water content, automatically it will form as a liquid gas. That means liquid glass, not gas, glass. It directly injected into the soil. That means the content of this chemical will have we have to inject, not we have to compact. Simply we have to inject. There may be difference between compaction and injection. In the compaction we have to use huge amount of vehicles. That means mechanical equipment we have to move on the surface of the soil. But in case of injections we have to use some amount of pressure at a particular point, not on the overall area. At simply at a particular points we have to use pressure. It is directly injected to the soil. It increases the strength of soil and makes it impervious. That means, see, in the previous case where in the previous first point we have discussed, it is a water glass. Normally glass will not allow water content because of their particle structure. Likely here also we are injecting the particular chemical into the land, so that those chemical will not allow water content to the soil, so that it will be simply acting as a layer, acting as a dispersing agent. Dispersing means simply a layer, that means that will not allow the content of water. It increases the maximum compacted unit weight of the soil. That means normally silica having a huge amount of density compared to other materials, so that by adding the silica content to the soil, automatically the density will be increases. The chemical required varies between 0.1 to 0.2% of the weight of the soil. That means in what content of the soil we have to doing this experiment. First of all, we have to measure the total area, and then we have to estimate what how much content of material will be used. That means we have to require, in what way we have to spread those, all those things we have to associate with the help of some expertise that expertise persons. Those will give some suggestions whenever we are doing this kind of experiments to improve the stabilization properties. Next one, the method is relatively inexpensive, but long term stability is doubtful. Why? Because the total material is like a glass, so that whenever we are applying a load on the structure, automatically the glass structure will breaks, and due to these fault areas, automatically water penetration takes place, so that this kind of principle is not suitable in all kinds of soils. For a small scale of periods, that means small scale areas, we have to go for this kind of stabilization. For large scale areas, this method is not suitable. The treated soil is may lose the strength whenever exposed to air and other groundwater conditions. That means air or groundwater conditions, because of in the air and the groundwater we are having some impurities and other toxic chemicals. Whenever the glass or any other sodium silicate content is reacting with another matter, automatically their reactive power will be decreases, and structure will be very breaking conditions. Next, polymers. Normally polymers, we have different kinds of polymers. Those polymers also here we are using as a stabilizing agents to strengthen the soil. Particularly polymers are long chained molecules. That means we have observed in our organic chemistry. In intermediate, polymer means CnH2n plus 2y. Likely we are having different compositions: methane, ethane, propane, butane, pentane, hexane. Likely depending upon the number of carbon content, we have to give the name to the structure. That means simply we are called as a long chain. Long chain means depending upon the number of carbon contents. If it is a long chain or short chain, we have to give. Formed by the polymerizing of certain organic chemicals called monomers. Monomer means normally a single atom. Poly means many. Number of monomers are combined to get a polymer. That means number of monomers simply bonded together, and they will formed as a polymer. They may be natural or synthetic. That means some of the polymers are simply forming as a naturally. Why? Because in the trees we are having some resins, and simply we are obtaining a rubber as a natural material. Rubber is also a one of the polymer content with some natural degradation properties. But in case of some artificial polymers also there, those are not degrading into our earth surface. They will takes a huge thousands of years for degradation into the soil. So that resins are natural polymers like calcium acrylate, and calcium acrylate is synthetic. Normally resins, whenever we are giving some quantity of force to a tree, automatically tree will give a drop by drop resins. That means liquid matter. Those are simply we will call as a resins. Those are naturally occurring polymers. But in case of calcium acrylate, it is a synthetic resin. When added to the soil, reaction takes place. Automatically, they will form strength, and they will not allow water content. Sometimes catalysts are added to monomers to the soil. They will form as a polymerization occurs along with the certain quantities of chain reactions. Normally, catalyst. The duty of this catalyst is to increase the rate of reaction and giving more amount of bonds between the particles. Likely, this whenever we are using these catalysts in the reaction, automatically the rate of reaction will be increases and automatically strength also increases. So that these catalysts are used in this process of stabilization of soil to improve the densification properties and strength properties and this layer formation. Next one is the chrome lignin. This lignin is obtained by a byproduct during the manufacture of a paper. Normally, nowadays we are using this paper as a huge quantity. Why? Because for study purpose and different areas, we are using this paper content. So that while we are preparing this paper, automatically some of the byproducts we have to obtain. So that we have to utilize those byproducts in a different ways. That means we have to use in both byproducts. Automatically we will decrease the pollution causing to the environment and soil. Simply here we are using those chrome lignin as a waste material. Normally we are using those waste material as a stabilizing agent to strengthen the properties of the soil. Chrome lignin is formed from the black lacquer in sulfate paper manufacturing. That means sulfate paper means we are having different papers like bond papers and white papers and color papers. Likely we are having sulfate paper also. Those are used for photographic agencies, likely to get color photos and other things. Next one, sodium bicarbonate or potassium bicarbonate is also added to sulfate liquor to form this chrome lignin. Sodium bicarbonate means Na2CO3 and simply K2CrO, potassium bicarbonate. Those things are added to sulfate liquor to form a chrome lignin. It is slowly polymerizing into a brown jet. Whenever this is added to the soil, automatically reacts the cause of binding particles. Normally, chrome lignin is not directly forming. Whenever we are adding these two contents to the liquor, that means these sulfate paper waste material, automatically those will form as a chrome lignin and those will form a brown layer. When this is added to the soil, automatically it slows the reaction and causing binding of particles. This quantity required varies between 5 to 20% by weight. Normally not by volume, only by weight it will takes 5 to 20%. So that we have to replace those waste coming from the paper industry in a effluent manner to get the strength. As lignin is soluble in water, to stabilizing effect is not permanent. So that lignin is not soluble agent in the water. So that we have to use in a prescribed soils only, not used for movement. So that means water moving soils. Other chemicals what we are using in different contents are waterproofers. Normally waterproofing agents we are using as a using in buildings to control the water flow from top stories to down stories, especially in rainy seasons. Next one, coagulating chemicals such as calcium chloride and ferric chloride have been used as a agents to electrical attraction and form flocculated structure in order to improve the permeability of the soil. Next one, dispersion. This means the dispersions normally we are using in paints and phosphoric acid combined with these water melting agents and automatically those will cause the cohesive soils. It reacts with the clay materials and form insoluble aluminum phosphate. These are the four other chemicals we are using. First one is the waterproofer. It is a chlorosilicanes and siliconates and amines and quadratic ammonium salts have been used for the soil waterproofing. That means soil waterproofing means on the primary layer we have to give this waterproofing agent so that they will not allow water content into the soil because of their chemical properties. They form as a top sheet to the structure. Those sheet will not entaining the water. Next one is the coagulating chemicals. Those coagulating chemicals are simply calcium chloride. In the previous case we are using this calcium chloride and magnesium chloride and sodium chloride. Next one is the ferric chloride, that means FeCl2, and have been used to increase the electrical attraction. That means electrical attraction means they will simply recharge as easy as possible, and they will attract the surrounding negatively charged ions. Simply Fe plus 2 we are having, automatically Fe plus 2 acts as a positive charged ions. Simply they will attract negative charged ions and forming bond. Next one is a dispersant, such as sodium hexametaphosphate, and used as to increase the repulsion and cause a disturbed structure that will compact the density of the soil increases. That means dispersion means automatically those will disperse the particles whenever there is a ion. Those ions, that means a normal molecule, those molecule will be dispersed into ions. CaCl2 is a normal molecule. Those molecule will be dispersed into Ca plus 2 and Cl minus 2, likely Cl minus and Cl minus, so that those positively charged and negatively charged ions simply react with surrounding particles and they will form it as a molecules. After the formation of the molecule, simply we have to go for densification. Simply we will get the huge quantity of densified soils. Next one is the phosphoric acid. It is a combined with the water agent and used for the cozy soils. It will react with the clay minerals and forms insoluble aluminum phosphate. This is the technique why we have to, that means in what way we have to spray those chemicals. Simply they are spraying as a water jet on the soil surface. After a few minutes, automatically those will penetrate into the layers, and the formation of particles will be takes place, and then we have to go for densification. This is also a spraying technique. Simply they are spraying with a high amount of force to the soil, so that there will be penetration into up to some content. That means 2 inches or 3 inches penetration will be takes place due to huge amount of force using. It is also a forcing technology. That means by using a jet of water, simply they are spraying that chemicals onto the soil. Why? Because in this particular case there will be slidings takes place whenever there is a forces acting on the structure. That means that is a totally hilly structure with rock mud strata. That means mud particles are simply losing strength whenever there is a force application on the structure, so that there may be some sliding of small rocks takes place. So that to arrest those sliding forces generated in the hilly areas, simply we have to go for these kind of stabilizations. Simply we have to spray the chemical content whichever is associated with the water. Those water we have to spray in a huge amount of force. Due to those force, automatically there will be some formation of bond, and there will be some stabilization takes place. Due to those stabilization process, there will be no sliding takes place in further times. It is a one case study they have taken. Okay, and tomorrow's class we have to go for another stabilization.